All right, so in this video, we're going to look at vertical and horizontal stretches or compressions. This little diagram here calls them shrinks. But you can either stretch a function or you can compress it or shrink it. So as usual, if you're looking at what happens on the outside, right? So if A is bigger than 1, so like 2 or 3, if you multiply f of x by 2 or 3, it's going to stretch vertically. All right, it's going to make it grow. Okay, and if you multiply it by a fraction, so like 1/2 or 1/3, it says if a is between 0 and 1, it's going to compress the function. It's going to make it smaller. And if you do stuff to the inside, it works backwards. Right? If the thing that you're multiplying is bigger than 1, so like 2 or 3, it's going to make it shrink or compress. And if you multiply it by a fraction on the inside, it's going to make it grow. It's going to make it stretch horizontally. All right. So I've got an example for you here, just dealing with x squared. And first I want to look at 2f of x. All right. So if we multiply by something on the outside, it should cause it to vertically stretch. Right? You can see the red one's the original, the green one's my new one. And it is steeper. All right, it has stretched it vertically. If we zoom in here, the way you can tell is by looking at the y values. If you see where x is equal to 1 and y is equal to 1, but if you look at the green one, the new one, the y value has doubled. X is still equal to 1, but the y value has jumped to 2. If you look at x equals 2, the original has the y value being at 4, but the new green one, it has stretched it all the way up to 8. Okay? So if you multiply by something on the outside, you'll get a stretch. If we had, instead we've done 1/2. All right? Okay, so this is going to compress the function. It's going to slow it down or squish it. If you look at 1 on the original, it's at 1, but the new one is half that value. It's actually 0.5 or half. If you look at it for x equal -2, you'll see the original is at 4, but the green one is only at 2. So it has cut all those y values in half. Okay. I will look at changing numbers on the inside now. So this is a little weird looking, but if we look at f of 2x, this is going to be a horizontal compression. All right. So remember the red one is your original. So if you take, let's say if we look at where the red one is at 1, we see that the x value there is -1. But if we look at where the y value, if we look at the green one, where the y value is 1, we see that this thing has been horizontally cut in half. All right, the x value is only at -1/2, right there. There you go. Where the y value is 1 here, the x value is half of that. If we look at where the red one is at 2, okay, so where the red one is at 2, we have a y value. Actually, let me use 4 instead. Where the red one is at 4, we have a y value, or sorry, an x value of -2. But on the green one, it reaches 4 when the x value is just half of that. It's at -1. All right. So that is a horizontal shrink or horizontal compression. You're taking the red one and you're squishing it this way, left and right. But if you do a fraction there, it makes it flatten, or it actually stretches it horizontally. All right, it's kind of like thinking of a vertical compression, but it's actually taking these x values here and stretching them out twice as far that way.